Have you ever talked to an AI and just felt like it's brilliant, but it's trapped in a box, totally disconnected from the real world? Well, today we're going to break it out. We're diving into how AI is transforming from this kind of isolated brain into an autonomous agent that can actually plan things and get stuff done.
So, what's the core problem here? Well, it's that a lot of these powerful language models are fundamentally isolated. They're trained on this massive but totally static snapshot of the internet. And what that means is they can't access real-time information. Their knowledge is basically outdated the second their training is finished.
And this slide just lays it all out perfectly. On the left, you've got that classic isolated LLM. You ask it for a flight, and it gives you this generic, kind of useless guess. But look at the right. The tool-powered agent connects to a real airline database and gives you a precise, factual, and actually helpful answer. I mean, that is the leap we're talking about.
So how do we do it? How do we give that AI the keys to the outside world? The answer is something developers call tools, and this is really the first critical piece of the puzzle for unlocking an agent's true potential.
So, when we're talking about AI, a tool is basically any external resource the agent can call on for help. You can think of it like giving the AI a phone so it can call a specialist. That specialist could be a flight search API, a company database, or even some custom piece of software. It's all about beefing up its internal knowledge with outside capabilities. What's really fascinating here is how this works under the hood. The language model itself doesn't actually run any code. First, it just decides, hey, I need some outside help here. Then, it writes up a detailed instruction. Think of it like filling out a work order. A completely separate system called the controller takes that order and actually executes it. And finally, the answer gets handed right back to the LLM, closing the loop.
And this quote just nails it. The LLM's job isn't to be the mechanic, right? It's the service manager. It's a super sophisticated dispatcher that intelligently figures out which specialist, which tool is needed for the job, and writes up the instructions perfectly.
And the toolbox these agents have access to, it's incredibly diverse. We're talking about APIs to connect to pretty much any online service you can think of, databases for pulling up information, custom utility functions for special calculations. You can even have hardware interfaces to control physical things like robots or smart home devices.
Okay, so the AI has this powerful set of tools. That's awesome. But just having a hammer and a saw doesn't make you a carpenter, right? How does the agent learn to use these tools together in the right order to actually achieve a complex goal? Well, that brings us to our next key ingredient.
So, we've given the AI tools. Now, we need to give it a strategy. This is where planning comes into the picture. It's the strategic brain that's going to direct how all those tools get used.
You know, AI planning isn't a new idea. But the old-school methods, like this one called strips, they were super rigid. They needed the world to be perfectly predictable, which, let's be real, that's just not how it works, especially when you're dealing with messy human language. Modern approaches, though, they're built to be flexible and to work with the natural strengths of a large language model.
One of the most powerful and practical methods is called a Hierarchical Task Network, or HTN. Now, it's a fancy name for a really simple and intuitive idea. You take a big, scary goal, and you just break it down into smaller, more manageable steps. And then you break those steps down, and you keep going until you've got a list of simple things you can actually do.
And this is a perfect example of what that looks like. The high-level goal, plan vacation to Rome, isn't something you can just do. So HTN breaks it down. First into big chunks like book travel and plan activities. Then book travel gets broken down even further into search flights and book hotel. This whole hierarchy turns a vague request into a concrete, step-by-step plan.
All right, so now we have the two key ingredients. We've got tools, which are like the agent's hands to interact with the world, and we've got planning, which is its strategic brain. And when you put those two things together, that's when the agent really comes alive.
And this right here is such a crucial point. If you have planning but no tools, the AI can create an amazing, detailed plan for a trip to Rome, complete with flight numbers and hotel names. The only problem? It will all be completely made up. The whole plan is just a work of fiction because it's not grounded in any real-world data.
This chart just shows you the massive jump in capability. An isolated LLM on its own? Yeah, it's useful for sure. But when you add tools, its ability to solve real problems just skyrockets because now it can access facts. And then you add that strategic planning layer on top of it all, and you get a system that can tackle really complex, multi-step tasks all by itself.
So here's the whole workflow in a nutshell. First, the LLM figures out what the user actually wants. Second, it uses its planning smarts to break that goal down into a sequence of steps, figuring out which tool is needed for each one. And finally, and this part is key, the controller executes the steps, and the LLM can actually adapt the plan on the fly based on the results it's getting back.
Okay, this all sounds great in theory, but how do developers actually build these agents? Let's take a quick look at some of the popular framers out there that provide the blueprints for creating these intelligent systems.
This slide gives us a really nice comparison of the different design philosophies. You've got LangGraph, which gives you really explicit control with a graph. Then there's Crew AI, which is more like a manager-worker model, and you have AutoGen, which basically simulates a group chat where different specialist agents all work together. They each have their strengths, but they're all built on the same core principles, combining a smart LLM with tools and a solid plan.
At the end of the day, if there's one thing to take away from all this, it's this. The next giant leap for AI isn't just about building bigger and bigger brains. It's about giving those brains hands to interact with the world through tools, and a strategy to use them effectively through planning.
And that leaves us with a really fascinating question to think about. We are building agents that can reason, that can plan, and that can act. They're moving out of the digital sandbox and into our world. So what are the big, complex, real-world problems in science, in medicine, you name it, that we should point them out first?